Hi, my name's Glenn Stock, and I've chosen the problem 439 plus 992 to explain to our Year 3 students. So the underlying maths concepts for Year 3 students is that, as per ACARA, they're supposed to be able to count up to 10,000s. In this case, we're only really needing to count up to 1,000. We are going into the second 1,000. So in this case, up to 2,000. So it should be reasonably easy for these Year 3 students. They do need to be able to understand the addition and the equal signs as well, which again, by Year 3, that should be, as per ACARA, that should be quite attainable. So here we go, 439 plus 992. I'm going to explain this in my own little way before I use any manipulatives and ideas that we've seen at the uni. I teach this with my kids all the time. So the kids understand, they need to understand in Year 3 that we're dealing with the 4s, the 100s. The 3 is the 10s, and the 9 is the 1s. 9 is the 100s, 9 is the 10s, 2 is the 1s. So we break it down like this. So the 4 is 4 100s. The 3 is 3 10s. The 9 is 9 1s. It's important not to say 4 times 100s, 3 times 10s. We keep the multiplication signs out of this. Again, we come down to the 9 100s, the 9 10s, and the 2 1s. Now, an idea about this, explaining this in the class I saw, which was quite handy, is a little table that the teachers are using. So if we give it the title 439 plus 992, obviously we're going to reach into the thousands here, so we're going to put a thousands column, then a hundreds column, then a tens column, then a ones column. And we'll separate those. And again, my way of breaking this down is just do the 9 plus the 2. 9 plus 2 is 11. We only put 1 mark in the ones because we've reached the 10 column. So we've got 1 in the 10, 1 in the ones column. 3 plus 9. Now I know it's 30 plus 90. But again, we like to break things down for the kids and make it simple. So 3 plus 9 straight away is an easy one for the kids. 12. Don't forget your 0. 0 is the important place value system. So 30 plus 90 equals what? 120. Okay, so we've got 1 100 and 2 in the 10s. One either side there. Okay. Lastly, we've got the 4 plus 9. Again, it's 400 plus 900, but keep it simple for the kids to work it out slowly in their own time. So 4 plus 9 is 13. 400 plus 900 is 1300. Add the 2 zeros. We've got 1000 and 3 100s. 1, 2, and 1 on the other side. So now all the kids have got to do is just tally this up. We have 1 1000, 4 100s, 3 10s, and 1 0. 1 4 3 1. The answer to 439 plus 992 equals 1 4 3 1. I like these tables because it's something very simple for the kids to use. If they don't have a calculator or aren't using a calculator in a maths quiz, they can just run that off the side in their little paper. Now for manipulatives, I think it's very important to use concrete visuals, especially if you have a multicultural class. I know for a fact, being in another country, you may well understand the people who are speaking the same language as you, but they have a different dialect. Kids who go home and speak different languages at home and then speak English at school may not be able to catch up on every word, especially when the teacher's on a roll and we're using our own dialect, our own words. And you can lose some of those kids. So concrete visuals are an absolute must. So what I've prepared here, it's my own little props. To represent the hundreds, we have a red rod, and that represents the 400. And this guy here represents, I'm going to put him over here so he's in line. He represents the 9. So we've got 4 and 9. Now, for the purple, we're representing, for the 10s, we're representing it by the purple rods. So I'm going to put that over to there. And we've got 9 little purple rods. That represents 9 10s, and that represents 3 10s. Our green rods, finally, represent our 1s. My props are dying, and my baby's hungry. So we have 9 rods there, and we have 2 rods there. So 439 plus 992 equals 1431. I think concrete manipulatives are an incredible thing for the kids. Visuals are very, very easy for them to understand, gets through to them, makes your mark. You can't put enough words into a lesson as what a visuals will give them, the kids, for understanding. So yeah, an absolute must. It's almost like you might feel you're repeating your lesson, but you're gaining the attention, and the whole class is going to understand it rather than just, you know, the top percentage or the mainstream kids. The bottom end kids may not necessarily be bottom end for intelligence. It's mainly just because of their understanding. If you give them concrete manipulatives, colourful rods, anything that can let them visualise something they see in the outside world, you're going to bring them along as well with the rest of the class. Thanks very much.